Hey everyone! Today, we are getting our hands dirty and building semantic IDs from scratch. We're going to go from a cool, abstract idea to a real, practical implementation. And to do it, we'll be using the massive My News dataset to show you, step by step, how to create identifiers that aren't just unique, they're actually intelligent. Let's jump in.
So what is a semantic ID? Really? Well, just look at this. On the left, you've got your classic item ID, N3778. What does that tell you? Absolutely nothing. It's a total black box. But now look at the right. The semantic ID is practically telling you what it is. Sports, golf, it immediately gives you context. We're going from a random string of characters to a meaningful address, and that one little shift changes everything.
So here's our game plan. We'll start with the big problem that traditional IDs just can't handle. Then we'll properly introduce semantic IDs and dive into the secret sauce behind them, which is something called quantization. After that, it's all about the hands-on build. We'll look at the huge performance gains, and then finally, take a peek at the wild generative future that this technology unlocks.
Okay, first up, the cold start problem. Now, if you've ever built a recommendation system, you know this pain. It's that moment a brand new item shows up, and it's the exact moment traditional IDs just throw their hands up and quit.
I mean, think about it. An ID like N37378 is a total blank slate. Your system has no clue what it is until people start clicking on it, right? So for new stuff, this makes it basically invisible. And in a world like news, where an article is hot for maybe a few hours, you can't afford to wait for those clicks. By the time the system figures it out, it's already old news, literally.
And that brings us right to the solution, semantic IDs. The whole idea is simple, but it's incredibly powerful. Why wait to learn what an item is about? Let's just build that meaning directly into the ID from the very beginning.
This is the golden rule, straight from the research paper that started it all. The core principle is that similar items should share the beginning of their IDs. So, an item that starts with 1021 is automatically, by design, closer to another item starting with 1021 than it is to one starting with 1023. This simple little rule about prefixes is the foundation for some ridiculously smart and fast systems.
So to put it a bit more formally, a semantic ID is just a sequence of codes, kind of like a set of nested labels. But the key is they aren't random. They're built in a hierarchy, with the most general, high-level information coming first and then getting more and more specific. It's meaning baked right into the ID structure.
So that leads to the big question, right? How do you actually do that? How do you take the rich, messy, complex meaning of a news article, which we usually represent as a big vector of numbers, and boil it down to a clean, simple sequence of codes? Well, the secret sauce, the real magic here, is a process called quantization.
The specific flavor we're going to use is called residual quantization, or RQ. And the key concept is iterative approximation. Honestly, the best way to think about it is like giving someone directions. Your first code is the big picture, like the United States. That's a rough start. The next code corrects that first guess. It's the residual, so California. The next one refines it even more, Los Angeles. Each step is just zeroing in on the leftover error from the step before.
Let's walk through it. Step 1. You start with your item's vector embedding. Step 2. You find the closest matching code from your first, most general codebook. Now here's the clever part, the residual part. You calculate the difference, the error, between your original vector and that code. Step 4. You take that leftover error vector and find the closest code for it in the next codebook. And you just keep repeating that, with each new code refining the mistakes of the one before, getting you closer and closer to pinpointing the original vector. Okay, enough theory. Let's make this real. We are going to walk through how to actually build this system from the ground up using the My News dataset. It's the perfect real-world test for our blueprint. If you're a Python developer, you can think of this whole thing as a simple three-step recipe. First, we turn words into numbers. We'll use a pre-trained model like SentenceBERT to create a vector embedding for every article. Second, we train our quantizer. We feed all those vectors into our RQ model so it can learn the best possible codebooks for our specific data. And third, we just put it all together. We take the metadata we already have, like category, and tack on our new RQ codes to create the final ID.
And just to be clear, we're not talking about some tiny toy dataset. The Mind Small dataset has over 51,000 unique news articles. Our system has to organize all of them, which means this process needs to be smart and it needs to be efficient.
Now this is where the rubber meets the road. It's a classic engineering trade-off. Look what happens with just 2 stages or 2 codes. The collision rate is a disaster.
45%. Almost half your articles are getting the same ID. No way. Now, 4 stages is nearly perfect, but the IDs are getting longer. And right there in the middle, 3 stages. You get a massive capacity of over 16 million IDs. The reconstruction quality is super high, and the collision rate is less than 1%. It's the perfect data-driven sweet spot.
And voila, this is what the final product actually looks like. We start with the known stuff, the human-readable taxonomy, sports, NFL. And then we just append the 3 learned codes from our quantizer. What you end up with is an ID that's readable, hierarchical, and absolutely packed with semantic meaning.
So we've built these fantastic IDs. Now for the fun part, the payoff. How does this actually make our system smarter? And maybe even more importantly, a lot faster.
It's almost beautiful in its simplicity. A user types in NBA championship results. Our system encodes that query into a semantic ID prefix, let's say it's 11258. Then the retrieval is just a dead simple prefix lookup. The system zips through and finds every single article whose ID also starts with 11258. No complicated vector math, no slow nearest neighbor search, just a lightning-fast match.
And when I say fast, I mean fast. I mean, look at these numbers. Even a super optimized library like Phase, which is the gold standard for this stuff, takes about 5 milliseconds for a search. A simple side prefix lookup, it's under 1 millisecond. That's not just a little better, that's a whole different ballgame.
Now, you might be thinking, hey, what about that tiny sub 1% collision rate we saw? It's a great question, and the fix is super elegant. If 2 different articles happen to generate the exact same semantic ID, we just tack on a little disambiguation token at the end. DIS1, DIS2, and so on. Problem solved. Every single item still gets a perfectly unique address.
Okay, for our last section, let's zoom all the way out. Because what we've been talking about isn't just a clever way to do faster search. Semantic IDs are a key that unlocks a truly generative future, and it plugs directly into the biggest trends happening in AI right now. Here's the big insight. By turning every item into a sequence of tokens, our semantic ID, we've basically invented a new language. It's a language for our items. And what are transformers and LLMs amazing at? Learning languages. This allows us to shift our thinking completely. Recommendation stops being a search problem, and it becomes a language modeling problem.
So I'll leave you with this final thought. What if your next recommendation system didn't just find the next item you might like from a giant database? What if instead it actually generated the item's ID for you, token by token, just like an LLM generates words in a sentence? That is the paradigm shift that semantic IDs make possible. Thanks for watching.